Okay. Next part two of this. What is the net capacitance if the two capacitors are hooked up in series? Right. So ends up put two capacitors together in series. That is, it is equivalent to just putting one capacitor in. But what is that net capacitance of that one capacitor? As a function, I guess, of C1 and C2, each of these capacitors. And we kind of talked a little bit about this on Friday. We came up with a qualitative argument that the net capacitance is going to be smaller than C1 and C2. This is kind of hand wavy, but it kind of makes a little bit of sense. C1 interferes a little bit with C2, making C2 appear smaller, or the other way. You can think C2 interferes with C1, making C1 appear smaller. So our kind of qualitative understanding is that that net capacitance is going to be smaller than C1 or C2. But let's go through the algebra of what we know and figure out what C net ends up being. So I'm just going to draw something here. I have to start over. C1 and C2. And there's going to be some delta V across these two capacitors, right? So there's going to be some voltage drop across C1 and C2. Maybe there's a battery hooked up here or something. I don't know. It doesn't matter. There's, let's just say, some non-zero delta V right here. And we know there's that formula, the QVC from the Home Shopping Network. QV, at least that's how I remember it. The charge on a capacitor is the voltage times the capacitance. And that makes sense. Higher voltage, more charges on these capacitors, higher capacitors, larger capacitors, also more charge built up on these guys. And let's kind of put some stuff here. This is our C net right here. And let's suppose there's 4 charges built up on the, I don't know, left or right. It's really confusing. This side of the C1, right? Kind of the front end side of C1 here. Now we know that means there must be 4 negative charges on the opposite plate because they kind of balance out. So I'm just going to put that here. 1, 2, 3, 4. 4 negative charges there. But if there's 4 negative charges, what must end up happening on this side of C2? There must be, due to conservation of charge, 4 positive charges on that side of C2. But since C2 has 4 positive charges, it must have 4 negative charges on that last side to balance it out. So that's, make these pluses bigger. Right, so that's going to be kind of the situation here, is there's kind of that middle with a positive and a negative, and the outsides have 4 positives and negatives. Now taking that down to the equivalent capacitor, I think that means there's 4 positives on one side, 4 negatives on the other, right? 1, 2, 3, 4, 1, 2, 3, 4. And you might notice that this side here is the same as this. This side here is the same as that right there. And let's just kind of put it here. Q equals delta VC. That QVC formula applies, to C net as well. Now, kind of going up here, let's take a look at what's happening here. So that for, I can break this voltage drop into delta V1 and delta V2, right? So that total delta V is delta V1 plus delta V2. So let's write that down. Delta V equals delta V1 plus delta V2. But delta V is Q over C. Just looking at this formula here. There's our sum of the voltages There's delta V is Q over C. Let's apply that to each of these. So there's going to end up being Q over C1 plus Q over C2. Q1 over C1 and you'll see what I'm about to write. Oops, that's a plus. Right, so what we kind of did was, here's delta V net, which is Q net over C net, Q1 over C1 from delta V1, Q2 over C2 from delta V2. But we also said that Q1 equals Q2, right? From over here, that these two must be the same, so the charges on each plate must be the same. That kind of makes sense that we can't have more charges here than over here. So these Q's are all the same. So it's just Q over C net equals Q over C1 plus Q over C2, or 1 over C net equals 1 over C1 plus 1 over C2. And of course, that does not make sense until I hold this up. 1 over C1 is 1 over C net equals 1 over C1 plus 1 over C2. And this is our equivalent capacitance here. So we'll put a box around that. And then in the next couple videos, we'll look at kind of that idea of what happens as C1 gets big, what happens as C1 gets small, or likewise with C2, and then kind of maybe a qualitative understanding why this ends up being smaller relating to kind of the math and maybe what's physically happening here. But let's push pause and see what happens in the next video.